In Solidity, operators are fundamental building blocks that let us manipulate data and make decisions. In fact, operators play a vital role and allow users to perform different operations on operands. Think of them as the special symbols or mini commands in code that tell the computer what action to perform on values and variables. They are like tools for crafting calculations, math, comparisons, and logical decisions in your contract. In this video, we'll explore the main categories of Solidity operators: arithmetic, comparison, logical, assignment, and a brief intro to Bitwise operators. Each type has its own role. For example, arithmetic operators handle calculations, comparison operators check conditions, and logical operators let us require multiple conditions at once. All of these are essential in smart contracts. Let's get started. Arithmetic operators. Arithmetic operators in Solidity work like math helpers that let us add, subtract, multiply, divide, and take remainders. For instance, we use plus to add two amounts, minus to subtract, multiplication to multiply, division to divide, integer division, and modulus to get the remainder after division. These are just like doing arithmetic in math class or adding apples in a basket. Addition adds two numbers. For example, 3 plus 5 is equal to 8. Subtraction subtracts the second number from the first. For example, 10 minus 4 is equal to 6. Multiplication multiplies two numbers. For example, 2 multiplied by 6 is equal to 12. Division divides one number by another using integer division. For example, 7 divided by 3 is equal to 2, since it discards the remainder. Modulo returns the remainder after division. For example, 7 modulo 3 is equal to 1. According to the Solidity documentation, arithmetic operators let you add, subtract, multiply, and divide numbers. These operators make calculations possible in smart contracts, for example, computing token totals or balances. Remember that Solidity performs integer division, discarding any remainder, no decimals. From version 0.8.0 onward, Solidity automatically checks for overflows and reverts the transaction if one occurs. The second one is comparison operators. Comparison, or relational, operators let us compare two values and return a Boolean result, true or false. For example, we can ask, is x bigger than y, or are these two numbers equal? In programming, comparisons are like questions the contract asks before taking an action. For example, requiring that a bid is higher than the current highest bid before accepting it. Equal to checks if two values are exactly the same. For example, 5 is equal to 5 is true, 5 is equal to 3 is false. Not equal to checks if two values are different. For example, 5 is not equal to 3 is true. Greater than checks if the left value is larger than the right. For example, 7 is greater than 4 is true. Less than checks if the left value is smaller than the right. For example, 2 is less than 10 is true. Greater than or equal to checks if the left value is larger or equal. For example, 5 is greater than or equal to 5 is true. Less than or equal to checks if the left value is smaller or equal. For example, 3 is less than or equal to 5 is true. In this example, calling the function compare with the numbers 5 and 3 would return false and true, since 5 is not equal to 3, but 5 is greater than 3. As the Solidity documentation explains, comparison operators are like truth-seeking detectives that return either true or false. They are used everywhere. For example, inside if statements or require checks. Require that balance is greater than or equal to amount, otherwise show the message not enough funds. The third one is logical operators. Logical operators let us combine or invert Boolean conditions to form complex logic. They work on true, false values. Think of them as gatekeepers for conditions. Logical AND returns true only if both conditions are true. For example, true and false is false, while true and true is true. Logical or returns true if at least one of the conditions is true. For example, true or false is true. Logical NOT reverses the truth value. For example, not true is false, and not false is true. Imagine security checks. A and B means door opens only if you have both, key A and key B. A or B means door opens if you have key A or key B. Does not A means not A, like if a flag is not set. In this example, calling the function logic with the values true and false would return false. True and false. Both conditions are not true, so both true is false. At least one condition is true, so any true is true. And not A is the opposite of true. Logical operators allow smart contracts to enforce multiple conditions before continuing. For example, saying, if the sender is an admin and the contract is not locked, then proceed means the action only happens when both conditions are met. The sender must be an admin and the contract must not be locked. Solidity also uses something called short-circuit logic, which means that if the first part of an expression is false, it does not even check the second part, because the whole expression can never be true. Now, assignment operators. Assignment operators let us set or update the value of variables. The simplest is just puts a value in a variable. But there are also compound forms that combine an operation with assignment. Think of assignment like storing or updating a value in your contract's memory. Simple assignment sets the variable on the left to the value on the right. For example, unsigned integer x is equal to 5, set x to 5. Add assignment adds the value on the right to the variable on the left. X plus equal 3 means x becomes x plus 3. Subtract assignment subtracts the value on the right from the variable on the left. X minus equal 2 means x becomes x minus 2. Multiply assignment, multiply the variable by the value on the right. X multiplied by equal 4 means x becomes x multiplied by 4. Divide assignment divides the variable on the left by the value on the right. For example, x divided by equal 2 means x becomes x divided by 2. Imagine a game where the score starts at 10. Saying score plus equal 5 means you add 5 points to the score, so now the total becomes 15. Saying score minus equal 3 means you remove 3 points from the score, and so on. In the example above, saying count plus equal 10 means the current count is taken and 10 is added to it. A shorter way of saying count is equal to count plus 10. As the Solidity documentation describes, assignment operators act like diligent scribes that assign and update values. They serve as bridges between calculations and storage, making them essential for updating state variables inside a smart contract. The last is Bitwise Operators, basic introduction. Bitwise operators work directly on the binary bits of integer values. They are not very common in higher level code, but it is still useful to understand them. Bitwise operators treat numbers as sequences of zeros and ones, combining them one bit at a time. You can think of them as tiny micro-technicians that manipulate individual bits in binary data. Bitwise and compares each bit of two numbers, and the result bit becomes 1 only if both bits are 1. Bitwise OR, the result bit becomes 1 if either or both of the compared bits are 1. Bitwise XOR, the result bit becomes 1 if the two compared bits are different from each other. Bitwise NOT flips every bit. Zeros become ones, and ones become zeros. Think of each bit as a tiny light switch. AND means the light turns on only if both switches are on. OR means the light turns on if at least one switch is on. XOR means the light turns on if only one of the two switches is on, but turns off if both are on. NOT simply flips every switch. The ones that were on turn off, and the ones that were off turn on. Here, 5 and 3 compared using the bitwise and operation produce the result 1. This happens because in binary form, 5 is written as 0101, and 3 is written as 0011. Only the last bit is 1 in both numbers. So the final result is 0001, which equals 1 in decimal form. Although bitwise operations work at a lower level, they can be useful for certain optimizations or for managing flags and settings. The key takeaway is that when you see words like an or used in a bitwise context, you will recognize them as bitwise operators. Operators are the tools that let smart contracts compute and make decisions. By understanding them and seeing these simple Solidity examples, you can write conditions like if balance is greater than price and is owner, or update values like total supply plus is equal to minted tokens with confidence. All of the above examples come from standard. See the official docs for more on each operator. And try to modify the examples above in Remix or your Solidity editor to see the results. If this video helped clarify how operators work in Solidity, please like, comment, and subscribe. Happy coding!